clutchless variable displacement AC compressor. Due to the ever-increasing fight for high efficiency and fuel economy, automobile manufacturers, especially in Europe, have developed the clutchless AC compressor. Sandon, being one of those compressor manufacturers, has developed a PXE series variable displacement AC compressor, which we'll use as a study example for this technology. On standard compressors, the belt turns a pulley with an electric clutch. When you turn on the A/C, the clutch engages, and the piston starts pumping to compress the refrigerant. There are two problems with this traditional approach. 1. A compressor needs a fair amount of power. In cars with small engines, the engagement of the clutch to activate the compressor puts a big load on the engine, especially if it is idling. 2. The compressor will produce low flow or not enough when the engine is idling, and high flow when the engine is at high RPM and possibly too much refrigerant flow. In 1985, Delphi then Harrison developed the V5 variable displacement compressor. In early 2003, Sandon launched the PXE variable displacement compressor for the VW Golf V and VW Polo. The E stands for external control valve. Later on it was given to many VW and Audi models. The PXE uses a variable angle swash plate, which functions as a form of camshaft, to convert rotary shaft motion into the axial motion of the pistons, which are located on one end of the swash plate. The swash plate inclination angle, also called the stroke, is controlled by an electrical duty cycle PWM signal. The signal is derived by the air control computer, from an analysis of ambient, interior temperature, engine RPM, and other parameters. A control solenoid in the PXE compressor regulates the flow of refrigerant, from the discharge pressure side or PD or pressure discharge or PD, to the crankcase pressure or PC, in response to the pulse width modulated, PWM electrical signal. The control device consists of a solenoid valve. Its position is the relationship of the solenoid, acting against a suction release spring. Maximum stroke mode of the compressor happens as follows. A high duty cycle signal to the control valve solenoid causes the valve to close the passage of PD or pressure discharge into the crankcase. A variable orifice allows gas past the piston rings to flow into the suction chamber. Pressure crankcase then reaches the same as the suction pressure. As the PS or suction pressure and pressure crankcase come closer to the same value, the average gas pressure force on the top and bottom of the pistons approach the same value, and the swash plate inclination angle increases to the maximum setting. A colder refrigerant is the goal here. The final result of the wider duty cycle control is a long stroke, higher horsepower requirement from the engine, and increase of refrigerant mass flow. Then there's also the modulated stroke control mode. The control valve has a mechanism which senses suction pressure. The change in capacity is achieved by the valve adjusting the flow of PD or pressure discharge refrigerant into the crankcase. A change in the pulse width modulation PWM value of the signal to the solenoid varies the force on the plunger in the control valve. A higher inclination angle can then be achieved. Finally, there's the minimum stroke mode or near off. With the solenoid signal off, the spring force opposed to the solenoid force opens the valve and a specific amount of PD or pressure discharge flows into the crankcase. Regardless of PS or suction pressure, the inclination angle is forced to minimum. Hence, acceleration becomes a higher priority due to less engine load than the cooling need as indicated by the PS or suction pressure. This allows an easy inigni start, optimum power during acceleration, and prevention of evaporator freezing. The compressor shaft always turns at engine speeds, so no electromagnetic clutch is required. Clutch failure is not an issue in this system. The compressor pulley has a built-in torque limiter slip clutch, to prevent drive belt loss if the compressor has an internal seizure. If the torque limiter clutch slips during a compressor failure, there is no belt friction and a lower compressor noise. The continuous movement of internal compressor components makes it necessary to always return oil to the compressor for lubrication of the continuously moving parts. This is normally accomplished by the use of a cross-charged thermal expansion valve or TXV. The cross-charge consists of two types of refrigerants in the sensing element of the TXV, that are made to provide normal control at normal conditions. When the TXV is set near the closed position, and refrigerant flow is small, the valve switches from positive to negative. Thereby, return of refrigerant with entrapped oil to the compressor is assured. These compressors, or a derivative technology, is making inroads into the present and future of automotive air conditioning systems. Deep knowledge of the system is a must today.